This is the fourth section of chapter 3, Flow in Networks 1, and this section is about flow augmenting routes. Now we've already found an initial flow for a network. Here we're going to be looking at augmenting, which means improving or increasing the flow through a network. And we're going to do this by increasing or decreasing the flow on some of the arcs. Now we do this by ensuring we do the following. So first of all, we label each arc with a forward and a backward arrow. The forward arrow, which is going to be the same direction as the arc, shows by how much the flow on the arc can be increased by. Now this is equal to the capacity of the arc minus the flow. So for example, if an arc had a capacity of 10 and it had a current flow of 7, then that means that it could be increased by 3. So we'd have 3 written by our forward arrow. And if we do the capacity minus the flow and that equals 0, that means that that arc is saturated, which means that we cannot increase the flow anymore on that particular arc. That's the forward arrow. Now the backward arrow, which is going to be the opposite direction as the arc, the direction of the arc, this shows by how much the flow on the arc can be reduced by. And this is equal to the current flow. So if an arc has a current flow of 6, it means that the flow on that arc can be reduced by 6. Now what we do, we start at S and we finish at T, and we find routes that increase the flow of the network. Now we can use forward and backward arrows to do this. Example 8. The diagram shows a capacitated directed network. The number on each arc represents the capacity of that arc. The numbers in circles represent an initial flow pattern. Starting from this initial flow pattern, use the labeling procedure to obtain a maximum flow pattern through the network from S to T and explain why your flow is maximal. You should list each flow augmenting route as you use together with its flow. So the first step is to label each arc with a forward and reverse arrow. Now, an arc like this one, for example, DE, this one going down is the forward arrow, and this one going up is the reverse arrow. So an arrow which is in the same direction as the arc will always be the forward arrow. The arrow which is in the opposite direction to the arc is always going to be the reverse arrow. Then we're going to go through each arc, and with the forward arrow we're going to label by how much that arc can be increased by. So for example, this one here, this can be increased by 5, so we do the capacity minus the flow, so that can be increased by 5. This arc here, okay, capacity minus the flow is 0, which means that that arc is saturated, we can't increase the flow there. Let's go to this arc here. So this can be increased, the capacity minus the flow, that's going to be 9, so I'll put 9 down there. This one AC, that can be increased by 3. BC can also be increased by 3. CD, that can be increased by 7. BE can be increased by 2. CE can be increased by 1. DE can be increased by 4. DT can be increased by 3. And ET can be increased by 7. So these numbers here, basically the capacity minus the flow, this is how much each one of these arcs can be increased by. I'll just put a note there. This one is saturated, so we can't use that to increase our flow, but we may find that we may decrease the flow on this to actually increase the overall flow. We'll see in a moment. Next, we put on the reverse arrow how much the flow can be decreased by, and that's going to just be equal to the current flow. That is the numbers in the circles. Okay, so our diagram is now ready. So starting at S, we're looking for a route where I can increase the flow. So at the moment, can't use this one because that flow is 0. I can't increase that, but I could increase this by 5. I could increase this by 9, for example. Now, it makes sense when you're doing these types of questions, rather than just use random routes. Start with A, like, at the top, and work your way to the bottom. So if I start here, I can see that root SACDT increased by 5, increased by 3 here, 7 here, and 3. Now remember, we take the lowest value that tells us how much I can increase the overall root by. So I can increase, and I'll probably highlight it, root S, A, C, D, T, that can be increased overall by 3. So let's write that down. Okay, so now we've done that, we do need now to change some of these numbers. So if I'm going to increase, let's say, this root here by 3, then that means, and I'll only write it down for this one, this flow is now going to be 18. Yeah, so it's 15, it's 3 more. It means that I can only now increase this by 2 because the difference between actual flow and the capacity is now 2. So this is going to be 3 less. Okay, so I'll cross that out and put 2. Okay, so what I've done, I've subtracted 3 from this number. But the amount that I can decrease this flow by is now going to be more than 15. It's now going to be 18 because the current flow is now 18. So this bottom number here will get increased by 3. So this will now be 18. Okay, so can you see what's happened? Decrease the forward arrow by 3 and increase the reverse arrow by 3. So that just saves time. It saves you sort of going back and working out what a new flow is. If you just remember, subtract the extra flow from the forward arrow, add the extra flow to the reverse arrow. So I've done it for this one here. So if I go on to the next one in my root, so S, A, so it's going to be A to C. So decrease by 3, increase by 3. So you can see what's happened is we've increased this flow by 3, so it now becomes saturated. That's why we've got 0. But you could decrease all 10 of the new flow from it if you wanted to. So basically, that's what that one becomes. Okay, I'll do one more and then I'll just quickly fill in the rest. So if we have, well, there's only 2 more to do, so I might as well finish them off. This one, decrease by 3, increase by 3, and then the last one here, decrease by 3, increase by 3. Right, so we're now looking to see if we can find any other roots we can augment or increase. Now, I know I can increase SA by 2, but the 2 roots that come out of A are saturated, so I'm not going to be able to increase either of these 2 roots. So there's no point going from S to A because I'm going to get stuck there. So I now need to go S to B, and I'm looking to see which route I can use to augment the flow. Now I'm looking for the largest increase I can make. Now let's say, for example, I go along here, so I can increase this by 9, this by 2, and then this by 7. So if I did SBET, the maximum I can increase the flow by is going to be 2 because you've got 9, 2, and 7. Okay, if I went, let's say, for example, SBCET 9317. So this route would only increase by 1. Are there any other routes? Now remember, I can go backwards along routes. That is an option. So let's say I do S, B, B to C. Then if I do C to D, so I've got 9, 3, 4. So far I can increase this by 3. And then here, I'm not going to go D to D because that's saturated. I'm not going to be able to get any increase. So S, B, C, D. And then if I go along here, that's an increase of 4 and then 7. So S, B, C, D, E, T has 9, 3, 4, 4, 7. I can increase my flow by 3. So that's the route I'm going to take. So we can increase route S, B, C, D, E, T by 3. So now I'm just going to go along that route and decrease the forward arrows by 3 and increase the reverse arrows by 3. So actually that should be 9 minus 3, 6, 15 plus 3, 18. And then B to C, decrease by 3, increase by 3, C to D, decrease by 3, increase by 3. You can see like there's lots of numbering on the diagram, so you need to be careful. So D and then E, so forward arrow, decrease by 3, reverse arrow, increase by 3. And then last one we're going to get to is E to T, decrease by 3, increase by 3. So let's see if there's any other routes that I can increase. So we know we can't increase any routes that go from S to A because they're saturated there. Let's have a look. We can't increase a route that goes SB to C because that's saturated, so we must go to C. So S, B, E, T. Now we've got 6, 2 and 4, which means that I can increase that route by 2. So we can increase route S, B, E, T. And when you do these types of questions, you must write down the route and how much you're increasing it by. We can increase that route by 2. So we'll write down the working for that. So take away 2, add 2, there, take away 2, add 2, last bit here, take away 2, add 2. Okay, so before I go any further, let's see if I can augment any further. So saturated, 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 saturated. So whether I go from S to A or S to B, I cannot go any further because I've got saturated routes. Now I've got a whole load of numbers here. So it might be useful just to circle these final numbers here that I've got, because I know that I can't augment my flow any further. So these are my final numbers, and probably what I'll do is I'll write those down on a fresh diagram. Now when you do these types of questions, don't cross out your working, leave your working, show what you've increased and decreased, and always show which routes you're increasing to augment your flow. So we now finish this question off, and the way that we do it is we're now going to write down the current or the new flow on each arc. Now the new flow is going to be the value on the reverse arrow. Remember, the value on the reverse arrow is the current flow. So SA, the reverse flow, is 18. So 18 is going to be the new flow. So write down 18 here. This arc here, SB, its reverse arrow is 20. So 20 is going to be the new flow. So I'll write down 20 here. A to D, its new flow is the same as the old one. It's still 8. So 8 there, the number on the reverse flow. So we'll put 8 here, and it's saturated. I think we've got others that are saturated as well now. A to C, this is saturated. Its new flow is 10. It was 7 before, so we've managed to increase it to 10. B to C, this one is saturated. Its flow is now 9. So we'll put that on 9. Then moving on to arc BE, its reverse flow is 11, or reverse arrow was 11, so its new flow is 11. C to E, we have a value of 8 here, so that's going to be the value of its new flow, 8. And C to D, we have 11 here, so that's going to be the value of the new flow, 11. So you've got to take care with your working, writing things out. It's easy to make a mistake if you're not careful. D to E, that has a value of 6 on its reverse, so the new flow is 6. I think that was part of it there, so 6. D to T, this is going to be 13. You can see it there, so we can take all of that out and put 13. And then last one down here, the reverse arrow is 25, so this flow is now 25. That's its new flow. So this is the answer to part B. This is my final flow pattern, and if we compare it to the initial one, this one had a flow of 30, so 15 plus 15, 10 plus 20, so that was the initial flow. Now this one has a flow of 38. You can see it there, what's coming out of the source. It's the same as what's gone into the sink. So although this is not part of the question, we can say that we've increased the initial flow from 30 to 38. So we managed to increase the flow by an extra 8 units by using this method, procedure, algorithm to do that, this flow augmenting route method. Example 9. The diagram shows a capacitated directed network. The number on each arc represents the capacity of that arc. The numbers in the circles represent an initial flow pattern. Part A, write down the value of this initial flow. So by either using the source or the sink, 8 plus 5, or we could do 7 plus 6, whichever one we do, we can see that we've got an initial flow of 13, and I guess in this question we want to try and improve that flow. Starting with this initial flow pattern, part B, use the labeling procedure to obtain a maximum flow pattern through the network from S to T, listing each flow augmenting route you use together with its flow. Okay, so I'll start with my forward and reverse arrows just to make things a little bit clearer. On this one, I've done the forward arrows in red and the reverse arrows in blue. Next, we put down on our forward arrows how much we can increase the arc by and how much we can decrease it by. So if we start with SA, that we can't increase it by anything, but we could decrease it by 8. A to C, we could increase that by 8, or we can decrease it by 4. C to T, we can increase that by 6, or we could decrease it by 7. SB, we could increase that by 6 or decrease it by 5. B to D, we can increase it by 5 or decrease it by 5. A to D, we could not increase it at all, but we could decrease it by 4. That arc is saturated. D to C, we can't increase that. It's saturated, but we could decrease it by 3. And then lastly, D to T, we can't increase that. It's saturated, but we could decrease it by 6. So now we're looking for a flow augmenting route. So we can't go S to A because that's saturated, so we're not going to get any further that way. Now if we go S to B, we've got 6. B to D, that's 5. And then if you look from D to C or D to T, they're both saturated, so you might think, well, there's nothing I can do. But remember, you can go backwards along arcs. Now if we go backwards along this one, we treat this like a forward arrow and this like a reverse arrow. So I've got 6, 5, I can increase by 4, 8 and 6. So when I go along this arc backwards, D to A, then this one is going to be the one that I decrease by 4, and this is going to be the one that you increase by 4. So when you go backwards along an arc, the actual arrow in the direction you're going becomes like your forward arrow, and that becomes like my reverse arrow. So that route was, so we can increase route S, B, D, and then backwards to A, and then C, and then to T. And those values are 6, 5, 4, 8 and 6. And the smallest of those, 6, 5, 4, 8, 6, is 4. So I can increase that route by 4. So let's write down our new values. So decrease by 4, increase by 4, B to D, decrease by 4, increase by 4. Now this is where we need to watch out. D to A, this is now like the forward arrow because that's the direction we're going in. So decrease by 4, increase by 4, decrease by 4, increase by 4, decrease by 4, increase by 4. Now we'll look again to see if we can find any routes to augment. SA routes, no, that's going to work because that's saturated. We already know that if we go SBD either to C or T, they're saturated, so we can't increase. And then we can't go backwards along this route here, D to A, because in a way this is sort of saturated, like backward saturated. And actually, what we've actually done is reduce the forward flow from A to D. We reduced it to 0. We can't decrease this flow anymore, but we could increase it by 4. So by actually reducing the flow from A to D to nothing, we've increased the total flow across the whole network. So we can't actually augment any routes any further. So we can do part C, which is now to write down what the final flow pattern is. Remember, that's the numbers that are at the bottom. So for arc SA, that's going to be 8. For arc SB, that's going to be 9. So we can get rid of all the others. For arc AC, that's going to be 8. So we'll take that out and we'll just put 8 there. For arc AD, that's going to be 0. That's the one that we use backwards. 0. Arc BD, that's going to be 9. So put 9 there. For arc CD, that's going to be 3. That's my backward arrow, the value of my backward arrow, 3. Then value of my backward arrow here is 11, so that's going to be 11 C to T, and then finally D to T is going to be 6. So that's my final flow pattern. And then part D, what's the maximum flow on this network? Well, by doing 8 plus 9 or 11 plus 6, we'll see that's 17. So we've managed to increase the total flow by 4, and that was the 4 from augmenting the route SBDACT. Example 10. The diagram shows a network of corridors represented by arcs. The corridors are those which will be used in evacuating a large cinema in the event of a fire. The capacity of each corridor is shown on each arc. The numbers in circles represent a possible flow of 41 people per second from S to T. In order for the building to achieve a safety certificate, it is necessary to show that it is possible for at least 70 people per second to pass from S to T. Part A, using the initial flow and the labeling procedure to find the maximum flow through the network. You must list each flow augmenting route you use together with its flow. So I'll start with my forward and reverse arrows, forward red, reverse blue. And here's my completed labeling. I'm going to make this much bigger to fill the screen so that we can get the numbers on. It's way too small to be able to write numbers on and see what's going on. That's better. Nice big diagram. So we're going to start to see if we can find any augmenting routes. So starting with route SA, SAF, no, it's saturated. So I can increase by 4, 10, 5, 9. The smallest of those is the 4. So I can increase, so part A, increase, what is it, S, A, D, F, T by 4. So I'll now put on my new numbers, decreasing the forward arrow by 4 and increasing the reverse arrows by 4. So I've done that, and I've just highlighted those values so you can see the changes. So let's look for any new routes. So I can't do any routes from S to A, that's saturated. Now SB is 22, not to D because that's saturated. 18, E 22, E to G 22, G to T 21. Wow, I can increase this route here by 18, SBEGT. So I'll now go along that route, decrease the forward arrows by 18, increase the reverse arrows by 18. So I've highlighted those values so you can see those changes. Right, let's see where else we can make changes. Now SB, anything from SB saturated, so I can't augment any routes going beyond B. So let's go to C. SC, so there's 10 there. C to E, that's 20 there. E to G, that's going to be 4 and then 3. But if I go 8, 5, I can get an increase of 5 rather than just an increase of 3. So we'll do route S, C, E, H, T. So I'll now go along that route and make those changes. So those changes have been highlighted so you can easily see them. And then if we go back to that route we were looking at before, S, C, E, G, T, we can actually increase that route. We've got 5, 15, 4, 3. We can increase that route by 3. Now we could have done this as the previous one. It doesn't matter, but I thought I'd just find the one that gives me the biggest increase first. But if we had done this one first and then the 5, it doesn't really matter. We'd still come up with the same solution. So now those changes have been made along that route and again highlighted so you can see them. Right, so we'll now look for see if any routes we can augment. SA, no good, saturated. SB, well, B to D and B to E are saturated, so that's no good. So SC, we've got to go SC. We can't go C to H because that's saturated. So we need to start SC, then to E. We can do that. We've got one spare capacity here to go to G, but we can't go G to T because that's saturated. But we do have the option of going backwards along a route. We could go backwards along this route, G to D, forward along this route, and then forward from F to T. And since we've got 2, 12, 1, and then this way would be 10, we treat it as a forward arrow again backwards along that route, 1 and 5, we can use that to get one more increase in our capacity. So we're going to increase SCEGDFT by 1. So here's my final labeling, and again the numbers which have changed have been highlighted. Now what we've effectively done is we've removed one person from going along DG, and now that person is now going along DF, which allows us to increase the overall flow of the network by 1. So I've now highlighted the numbers which are going to be my maximal flow pattern. Now I wrote 27 there before. That was incorrect. I should have written 29, where I should have added 1 to this number. I subtracted 1 by mistake. So that should be 29. So let's put this maximal flow pattern on. That'd be answer to part B. Okay, so there's my completed diagram, and then part C. Will the cinema achieve its safety certificate? Now it says that at least 70 people per second need to pass from S to T. Now the flow is, if we use the source 15 plus 28 plus 29, which is 72, they need to get 70, so the cinema will get or achieve its safety certificate. So well done, cinema. They will get their certificate. So you should now be able to do exercise 3D on pages 96 to 98 of the textbook.